Hello friends, welcome to Learn Infinity. In this video, we will discuss some of the solutions to the questions of the book Parker Smith. In B.Tech, some of us may have heard about this book at least once, but hardly try to solve the problems. So in this video series, we will see some of the interesting problems and try to solve them. So let's start. So we will solve today the DC machine part, question number 3 of the book. Here is the question. If constant values are assumed for the magnetic and electric loading of a machine so that weight of the active material is approximately proportional to the full load torque. This is the question. We have to prove that the full load torque is proportional to the weight of the active material. So let's understand the question more. So it is saying magnetic and electric loading is equal to constant. So magnetic means phi, maybe for magnetic it means maybe phi, for electric it means current, like that. It is saying some magnetic and electric loading is constant. We will see about the magnetic and electric loading sometimes after. So it is saying this is constant, then prove the full load torque produced by the shaft is proportional to the weight of the machine. So torque is proportional to the weight. It is saying to prove torque is proportional to weight, where the condition is the magnetic and electric loading is constant. So let's see how to proceed. If T is the full load torque, we know that torque equal to force into distance. This is the very basic formula of torque, force into distance. So if this is a circular shaft, circular cross section of the shaft, if this is a circular cross section of shaft and here force is being applied, then torque equation is T equal to F into R, where R is the radius. R is the radius and torque is F into R, or you can write F into diameter by 2. So T equal to F into R Newton meter. Let's assume it is the first equation. Then we know power equal to work done in one rotation divided by time taken for one rotation. Work done in one rotation divided by time taken for the one rotation. And where work done equal to force into distance, where work done equal to force into distance. And what is the distance? Distance is the circular distance. Distance means circular distance. If R is the radius, what is the perimeter? Perimeter will be 2 pi r. So here distance means 2 pi r. So work done equal to force into F into 2 pi r. Let's assume to be the third equation. From 2 and 3, we can say P is equal to F into 2 pi r, which is work done, divided by 60 by N, where N is in RPM. N is the speed in RPM. RPM means rotation per minute. How many rotations in minute? That is N. So if it's doing N rotation in 1 minute, so one rotation will take 60 by N second. N rotation in 60 seconds. So one rotation in 60 by N second. So that is here written 60 divided by N. Then we can take the N to the numerator. So it will become P equal to 2 pi N F into R divided by 60. This is the expression for power. So again from 1 t equal to f into r. So by putting this value t equal to f into r, here f into r equal to t, if we put t, then p will become 2 pi nt by 60. P equal to 2 pi nt by 60 watts. If we write t, if we want to take t this side and p this side, so t equal to 60p by 2 pi n Newton meter, and this is the expression for torque. So t is equal to 60p by 2 pi n. So by cross multiplying t into 2 pi n equal to 60p, we know that power equal to E into EA, E into IA. We know that P equal to VI, so you can write equal to E into IA. IA is the armature current, E is the generated EMF, and in DC machine, what is the generated EMF? EMF is equal to poles into phi. We usually write E generated equal to P phi Zn by 60A, where P is the poles. So don't confuse with power. So here P is the poles. So if you write E equal to poles into phi Zn by 60A, where P is for the poles. This P is power. So if you substitute the value of E here, then you get this equation. T into 2 pi n equal to 60 into poles or P into phi Zn by 60A into IA. So here 60 and here 60 will be cancelled. Finally we will get this T equal to 1 by 2 pi n into poles or P into phi into Z IA by A into n. By rearranging this equation, by rearranging the previous equation, by rearranging this equation, we will get this equation. So here n and n will be cancelled, and we consider poles into phi equal to B into pi dl. How? P phi or poles into phi equal to total magnetic flux per loading. Total magnetic flux or loading, we can say this is the magnetic loading. Magnetic loading. So how do we define magnetic flux? Flux equal to B into total surface area. B means flux density, where B is the flux density. B is flux density, and if we multiply flux density with the total surface area, you will get the total magnetic flux. So that is what it is written here. So P phi equal to B into pi dl. Here surface area is pi dl. How? If you consider the cylinder here, cylindrical machine, and this is the diameter, and this is the length, and total surface area is given by pi dl. Total surface area of a cylinder is given by pi dl. I mean surface area. How do you calculate the surface area? So pi d means this length the perimeter part into L. If you multiply pi d with L, you get the surface area. So B into pi dl. Similarly here, Z into Ia by A, we consider as total electrical loading. And total electrical loading, we can say it is equal to ampere conductor per meter. Ampere conductor per meter of periphery into ampere periphery. Ampere conductor per meter of periphery, we denote it as AC. AC is the ampere conductor per meter of periphery, which is then multiplied with ampere periphery, will give us the total electrical loading. So Z into Ia by A can be expressed as AC into pi d. And here we saw that armature periphery is pi d. So coming to the term AC, what is the meaning of AC? Ampere conductor. Ampere conductor. So you may not have heard about this AC before, but we have heard about ampere turn per pole. We have heard about the ampere turn per pole. Definitely we have heard about the ampere turn per pole in DC machine. So we define ampere turn per pole as Ia by A, where this capital A is the number of parallel path, into Z by 2P. Here P is the number of poles. As we know, 1 turn equal to 2Z. 1 turn equal to 2 conductor. So ampere conductor per pole will be Ia by A, Z by P. Because if you say Z by 2 is the number of turn, if you say Z by 2 is the number of turn, then Z is the number of conductors. I mean, if this is a turn, there are 2 conductors. Here is 1 conductor and here is another conductor, 2 conductors per 1 turn. So if Z by 2 is the number of turn, Z is the number of conductors. So we can say ampere conductor per meter of periphery AC equal to Ia by A into Z. So here we have written ZIA by A equal to AC into armature periphery. So if you take this last expression, this expression as equation 5, so equation 5 can be rewritten as this: T equal to 1 by 2 pi B into pi dl, which was P phi, and AC into pi d, which was ZIA by A. So pi d is the perimeter. You can see if this is the diameter. If this is the diameter, what is the perimeter? This length is perimeter or periphery. This length is pi d. And if this length is L, what is the surface area? Surface area is pi d L. That is what written here. So you can write as B into AC into pi d square L. B into AC pi d square L. Now one of the pi and pi will be cancelled, so only one pi will remain. D into d square. L is written here, B is written here, AC is written here. So B into AC pi d square L. This is the expression we got for T. So this is the expression we got for T. If now B and AC are constant, so this is the magnetic loading part. Here it is saying magnetic, and AC is the electrical loading part. AC is the electrical loading part. So these two terms are constant. T equal to half PAC pi d square L. These two terms are constant. Then you can say T is proportional to pi d square L. Pi d square L nothing but this. If this is D and this is L, pi d square will give you the volume. Pi d square will give the volume of the cylinder. If you assume the machine to be cylindrical, then pi d square L will give you the volume of the cylinder. So the volume of active material is proportional to torque. Hence, weight is proportional to torque. So this is we have to prove that torque is proportional to weight. Torque is proportional to weight. So we have proved that torque is proportional to volume, and hence volume is proportional to weight. So torque is proportional to the weight. So we have proved that torque is proportional to weight. So how you solve this question? These are the steps we solve the question. First we expressed T as first we express this T equal to 60p by 2 pi n. Then we substituted the formula for the P. Then we substituted the formula for P. We wrote P equal to E into IA, and we write E is equal to P phi Zn by 60A. We substituted these values in this. Then we expressed P phi equal to B pi dl and Zia by A equal to AC into pi d. And in the final expression, pi d square is nothing but the volume. So if B and AC are constant, then torque is proportional to volume, hence torque is proportional to weight. These are the steps we follow to solve this question. So that's for all today. Hope you guys enjoyed the video. Thank you. See you next time.